And now, let's welcome a presentation from HBK showing how they redefine vehicle validation workflows. Join Christof Salcher as he unveils HBK's groundbreaking approach to bridging the gap between simulation and physical testing. Explore HBK's vision of empowering the innovators through cutting-edge solutions that deliver true multi-physics data insights. Discover how HBK optimizes key parameters in the automotive industry, from ride and handling to durability and reliability, accelerating time to production.
So the plot, I'd like to start with HBK's vision. Ben took already this part. I'm hopping over this one. I'm going to then, second point is durability. Third point is vehicle dynamics, ride and handling, ADAS, and NVH, and the summary at the end. So first of all, HBK vision. I can stop over this one. Ben already explained it. What we as HBK stand for is basically exceptional tools gaining data insights for quick decision making, you can say. Let's go into durability. Not so much of a topic here. What we did is basically explaining the workflow. We reinvented last century V model. So we revitalized this to say, okay, let's go on preliminary design phase, virtual testing, then we have an implementation into a prototype, and then going up the right-hand side towards system integration tests, towards a full-scale test, and towards SOP. And we share this with the left arm, right arm to say left arm is around the virtual design and the virtual validation, and right side is about physical testing and model validation. In durability, we come here early in the product in the engineering phase. First step is FMEA tools to deliver. Second one is in the virtual testing world. We have fatigue, lifetime simulation models to basically simulate a structure, a part in an early phase before going to have a first prototype. And then on the way up, we can basically address road load data acquisition with our instrumentation, instrumenting basically a vehicle for a proving ground test in durability. We can help and support in material classification, also needed in virtual testing and also in full-scale testing. On the right arm up, we have basically the full measurement chain, which makes us unique in the market, coming from sensors to data acquisition to software and then to data analytics, basically, and the same for full-scale testing with our partners. How do we bridge this? The bridge the gap is basically data analytics, correlating the virtual world and the real world. And this means going into bidirectional. So we have customers using the data from the field, the data from the field to basically improve their models. For example, for tires, we already know, but also for full-scale vehicles. But it's also going to the other direction, for example, with virtual sensors, basically linking into the real-world physical data to complement some missing sensors. How does it look like in real with some pictures? We see on the left side the fatigue simulation based on finite element analysis, where we use virtual sensors in a finite element analysis model. This is led to data analytics, supported by, as I said, from proving ground road load data acquisition tests we basically do with real sensors, and then in data analytics we have at the end create a mission profile regarding the lifetime of the vehicle, and this mission profile can go in return to fatigue simulation, but also into bench rig testing for accelerated lifetime testing. All in all, we're talking about correlation of virtual testing, simulation, and real-world testing data. And as I said in the beginning, add virtual sensor data into real-world sensor data is a trend we see here to basically go more into zero prototype also. Next episode is vehicle dynamics, ride and handling. This is, I think, where we are here. The same here, the V model is a nice explanation and workflow here. What we see here is the VI grade, DIM, driver in motion. Before we have even a prototype, whereas I know there's an ambition to have 0 prototypes. Going up, on the other hand, is mobile data acquisition, what we see in a lot of customers using mobile data acquisition, doing ride and handling, vehicle dynamics, brake testing, and so forth, means also for model validation. And then on the right hand, going up with our equipment, supplying the complete sensor setup with acceleration transducers, support of wheel force transducers, strain, and so forth, and also data acquisition and software. And this is same for full-scale testing. And how do we bridge basically the gap? It means by data analytics, again, correlating real and basically simulated world. How does this look like in picture? I start with the upper left. Simulation, complete model in the loop, software in the loop. You've seen this already in the other presentations. And the simulation here is virtual testing is multi-body simulation and software in the loop or X in the loop. And then on the left side, lower left side, lab simulation, the driver in the loop and driver in motion, the DIM, where we see realistic scenarios, driver behavior, ADAS, HMI, and so forth. And on the right-hand side, supporting by proving ground testing with inertial measurement unit support, wheel force transducer support, GNSS, and so forth. Looking at this setup, but also the bench testing plays a role in here with tire testing, where we have customers like Michelin and Pirelli and all the others. And at the end, again, in the middle, data analytics to do test validation, model optimization, and the correlation of the two, where we have the right tool set. NVH is pretty much the same picture, where we see the two are combined then in a multi-model. Same V model, nice explanation point, design and virtual validation on the left side, and on the right side, physical testing and model validation, where we have here also finite element analysis going into the analysis of the model and simulation, and then we have the NVH simulator on the left side, also basically combined with mobile data acquisition and testing, and on the right-hand side up with the complete measurement chain from sensors, data acquisition, software into full-scale testing. And how do we bridge the gap is, again, data analytics and correlation between the two worlds, virtual and the real world. Getting some pictures. CAE, computer-aided engineering, the NVH prediction is basically complete model in the loop and model simulation. But on the lower left side, you see the NVH simulator looking at sound, vibration, the visuals. And on the right side, again, support by proving ground testing, looking at the NVH parameters with the complete measurement chain from sensors to data acquisition to software, doing the data analytics here, where we are unique in the world with the pass-by, whether this is indoor or field pass-by. This is the complete offering where you see the right hand in the middle, but also lab and rig testing still plays a major role with the modal test and source path contribution, but also noise source identification plays a role in that NVH world, and not only in R&D, but also in production. So all in all, it comes back to the same game, the correlation between the two, correlating virtual with physical world in data analytics bridges the gap here. So message and summary of that presentation. I was asked to do a presentation last week, so I was really on short notice how to bridge the gap in front of all simulator guys. I was once myself only a simulator guy, and I always said, okay, physical testing is actually not needed, and this was 20 years ago. The summary. So durability, ride and handling, and ADAS, NVH are main attributes. That's what we've heard a lot of times in other presentations. For end users, this means the key factors here is quality, reliability, safety, comfort, and the DNA basically of a vehicle that has been mentioned several times. To us, correlating simulation data and physical data is actually key to our road to zero prototype, because both can basically learn from each other. Point is also for us as HBK, a seamless and efficient workflow speeds up decision making and basically reduces costs.
So we don't have a problem that there is more simulation than physical testing, but bridging the gap is basically coming now more and more, instead of 10 years ago, from virtual to physical and not vice versa. 10 years ago, we said we need to bridge the gap from physical to virtual. Now we need to bridge the gap from virtual to physical. That's been also discussed with a lot of university professors. They say the young students start with simulation and not with physical testing, and they do hard to bring basically a strain gauge and an accelerometer to a vehicle, but the other way around is easier. So a seamless and efficient workflow speeds up decision-making and reduces cost. And there is another hypothesis which came up in the last 2 years, basically, that networked vehicles will generate tons of field operational data and to be analyzed in artificial intelligent machine learning stuff. And so getting an even sharper picture of true customer use cases and flow. And so I think there is room for more to come, that we not only talk about R&D, but also in operation use cases, and again come back to data analytics, streaming back that data into basically use case analysis and to the perfect setup, whether this is simulation or for physical testing. And this is where it ends. And so I thank you very much. Thank you very much also for the invitation so far. It has been an outstanding event.